The next question asks us to explore the average deviation of the mean using Statcrunch. Here we are in Statcrunch. We're going to open Statcrunch. Question 8 asks us to enter the two data sets, naming the columns as given. So I'm going to call the first column A and the second column B for data set A and data set B. Data set A had the numbers 1, 2, 3, and 4. Data set B had the numbers 0.5, 2.5, 2.5, and 4.5. Now we are asked to find the mean of these numbers, find the average. There's only 4 numbers in this data set. You could find the average by hand, but let's run summary statistics in order to calculate these values. And we can do it at the same time. So let's do summary statistics for the 2 columns that we've created. And I'm going to select both of these columns and click compute. And here is the data set summary that we get. The mean for data set A is 2.5. And the mean for the data set B is also 2.5. So even though they had different numbers in their data sets, they had the same average. Question C asks us to create a dot plot for this in Statcrunch. So I'm going to stay in Statcrunch and create a dot plot. I'm going to graph a dot plot. And I'm going to, again, I'm going to select them both. And I'm going to click compute. And here are our dot plots. The question is asked, do I think that the data is spread out for data set B and data set A? Are they the same spread? I don't think so. I feel like B is more spread out. There's 2 points that are further out, whereas A seems a little bit closer together. So I really don't think that they have the same measure of variability. The last thing that we're asked to calculate before I head back into our notes is what the range is for the data set. And our range is actually in the summary statistics. The range is the maximum value minus the minimum value. So for data set A, 4 minus 1 is 3. And for data set B, 4.5 minus 0.5 is 4. So B has a larger range. We're going to head back to our notes now to continue working through these guided notes. Just to recap, we calculated that the mean for data set A and B were both 2.5. And we said that data set B looked a little bit more spread out when we calculated the dot plot. And then the range for data set A was 3 and the range for data set B was 4. Now the next question that we're asked is to calculate the average deviation of these 2 data sets. So we're going to do that in the table below. We are going to calculate the distance. So we're not calculating deviations here, we're actually calculating the distance from the mean for each of these values. Remember that the mean for each data set was 2.5. So we're calculating the absolute value of 1 minus 2.5. That is the absolute value of negative 1.5 or 1.5. The absolute value of 2 minus 2.5 is the absolute value of negative 0.5 or 0.5. The absolute value of 3 minus 2.5 is the absolute value of positive 0.5, which is also 0.5. And the absolute value of 4 minus 2.5 is equal to the absolute value of 1.5, which is also 1.5. Then I'm going to add those 4 numbers together and divide by 4 to find the average of those deviations. 1.5 plus 0.5 is 2, plus 0.5 is 2.5, plus 1.5 is 4. So that is 4 divided by 4, which is 1. For the second data set, we take the absolute value of 0.5 minus 2.5, which is the absolute value of negative 2, which is 2. We take 2.5 minus 2.5 absolute value, which is the absolute value of 0, which is 0. We take 2.5 minus 2.5 again. Then we're going to take 4.5 minus 2.5 absolute value, which is the absolute value of 2, which is 2. Adding that together, we get 2 plus 0 plus 0 plus 2 is 4. And 4 divided by 4 is also 1. Now it says, hopefully, these results will give you motivation for a different way to measure variability around the mean that will give you a different value from the two data sets. Because when we looked at them, they don't look the same. They don't look the same in terms of spread out. So we need a different measurement. We are going to, it says this measure of variation about the mean we will consider the standard deviation is going to place heavier emphasis on where the data values are in relation to the mean, which is what we need. We're going to go back to Statcrunch and load the cereal brands data set, and we're going to compute a histogram.
Question 9 asks us to load the cereal data set that we've been working with in Statcrunch, where we're going to be working with fibers and sugar. And we want to make histograms that are on the same x-axis. So we're going to display 1 row and 2 columns. That's the directions that came in the guide notes. We're going to go to load, shared data set, and we search for cereals. We want the Statcrunch featured. And then we're going to graph histograms. We graph histograms, and we want fiber and sugar.
In the directions, we're told to display on the same x-axis, and we want 1 row by 2 columns, which is down lower in the settings. So if you scroll down, you'll see use the same x-axis, the very bottom, and 1 row by 2 columns. Those are the adjustments we needed to make, and now we're going to compute. We're going to copy this and paste it into our notes and then answer questions about the data set. One thing I do know is that we're also going to be using summary statistics. So I'm going to go ahead and calculate those summary statistics and head over to the notes to copy and paste those as well. I'm going to go to summary stats by column for fiber and sugars. And I'm going to copy and paste those as well. Okay, now we have our 2 histograms and our summary statistics. We can answer the questions below. So the first question is, just by visual inspection, estimate the mean of each data set. What will the relationship be between the mean and the median of each data set? So estimating the mean is trying to figure out where is the middle of this data set, where's the average? And when you're talking about a data set that's symmetric, the average is typically in the middle. When you're talking about a data set that is skewed, the average is pulled a little bit closer towards the tail. So for fiber, we have a skewed distribution. And in a skewed distribution, the mean is always towards the tail. So in this case, the mean is going to be greater than the median in this fiber distribution. So the median will be less than the mean. And for sugars, it's a little bit more symmetric. So we could say that the median is roughly the same as the mean. I would estimate the mean of fiber to be right in probably this highest bar here, just because there's a lot of data set there. I actually can see what the mean is in the summary statistics, but I would say for sugars, I would be right about in the middle here. The next question says, use Statcrunch to calculate the mean and median of each data set. And then it says, which of the 2 data sets is going to have a larger standard deviation, meaning which one is more spread out. And I think that sugars is more spread out than fiber. Fiber has all of their data really close together, except a few of those outlier data points. So I think sugar is going to have a larger standard deviation. Okay, the last couple of questions asked us to calculate the interquartile range and the standard deviation, and then which measure of center and spread is best for the data set. Remember, that comes down to the way that the distribution is shaped. For fiber, the range again is listed on summary statistics. Looking at that, that's 14. The interquartile range, remember, is found by taking Q3 minus Q1, which is 3 minus 1, or 2. And the standard deviation, which I'm going to abbreviate here, is 2.383. For sugars, the range was 15. The interquartile range was 11 minus 3, which is 8. And the standard deviation is 4.379. Notice how the range for fiber was 14, but the interquartile range and the standard deviation are both roughly 2. And then the range for sugars is 15, the interquartile range is 8, and the standard deviation is 4.37. So again, the IQR for fiber is probably better because it's skewed to the right, but for sugars, we want to use the standard deviation. So fiber is skewed right. So we are going to use the median for center and the IQR for variation. And then sugars is roughly symmetric. So we're going to use the mean for the center and standard deviation for the variation or spread. And that is it for this section. We are going to move on to a different topic in Module 11. We're going to start talking about bivariate data, where we have 2 different data sets together, and we'll talk about associations with that. So we are kind of exiting univariate data and moving on to correlation and linear regression. Thanks for watching.